Hi there. So today we're going to look at basically the Newton's second law, F equals ma, and we won't consider friction, but what we're going to do is have more than one object. So let's say if I have a block here and say that's 6 kg, and I have another block here that's say 2 kg. And they're both on some kind of smooth surface. I know it doesn't look very smooth here. And we apply a force here of, say, 12 newtons. And so the question is, well, we treat these together as a single object. So the question is, well, what is the force that this guy applies on that guy? What would that force be? We know we're applying 12 newtons here. We know this thing is going to accelerate. But what we're asking for again is what's the force between these two guys? And so I hope you can see that they'll obviously be moving with the same acceleration. They have the same motion because they're two boxes that are connected together, kind of like one rigid body. So if I see that I'm applying 12 newtons to a total mass, assuming it's one piece, then it's just 12 newtons divided by 6 kg, and that's going to give me 2 meters per second squared. That's my acceleration. Again, all I'm doing is using F net equals ma, and F net, there's only one force because we said there's no friction, and of course our Fn and our Fg are canceling each other, and they have nothing to do with the motion in this direction, so I'm not even going to write them down. So then we move on to the second argument. We say, okay, well, this is a block that has a mass of 6 kg, and we just figured out it has an acceleration of 2 meters per second squared. And so the net force on this must equal 12 newtons. I mean, that again is being forced by Newton's law. So then you could say that the force that the 2 kg box has on the 6 kg box is going to be 12 newtons. 12 newtons is the force that is being applied by the 2 kg box onto the 6 kg box. A question that could be asked just as well, what is the force that the 6 kg block pushes back on to the 2 kg blocks? It's basically asking just the opposite. If this is applying a force of 12 newtons here, what's the force that this guy applies back on there? And I hope you, at that point, want to reach out to Newton's third law that tells you that the force that object A applies on object B is the same force that object B applies back on object A. And not only is it the same magnitude, it's opposite in direction, but it's the same kind of force. There's a contact force or normal force in both cases. And so the force, if this one's positive, that one would be negative, so you simply write that as negative 12 newtons. So this is really a restatement of Newton's third law, which is say the force of A on B is equal to the negative force of B on A. Okay? So that's really simply how you'd handle 2 blocks. If you had 3, you'd do exactly the same. Let's say for the 2 kg, a 4 kg, and a 6 kg. And I was applying a force here of, say, 24 newtons. So again, you'd see that if I were doing that, this would be 6 and 4 are 10, and 12 kgs altogether are being pushed by a force of 24 newtons, again giving me 2 meters per second squared. You know, I kind of, fudge those numbers to come out again. All right, no matter. Same thing. So now the next thing is, well, what is the force that the 4 kg box has on the 6 kg box? And again, you look at the 6 kg box in its entirety itself. So, well, 6 kg, and it has an acceleration of 2 meters per second squared. So the net force on it must be 12 newtons. So this force that the 4 kg box applies on that is 12 newtons. Of course, he applies 12 newtons back, but we're just looking at this. If we were to ask the same question here, what is the force that the 4 kg box has on it pushed by the 2 kg box. And so if you look at this, you see the force the 2 kg box has on the 6 kg. If you look at this guy's entirety and say his net force, since he's moving, must be 2 meters per second squared. So the net force on him must be 8 newtons. Okay, well, let's see how this keeps going on. And of course, we're applying 24 newtons up here. So off that 24 newtons, you say, well, does that mean that this guy is getting 12 newtons of the entire force coming in, and this guy's getting 8 newtons of the entire force coming in? That's 12 and 8, that's 20. And then 4 newtons is going to this guy. And so, well, I'm giving 24 newtons to this guy. Well, we're going to start looking back and seeing, well, what is the reaction force? Because remember, they're pushing back as well. So you are putting a net force of 4 newtons to him because you have 20 newtons coming back from there and 24 newtons from here, hence giving you that 4 newtons. So it's intuitively not clear to you that how could this be having 4 newtons, 24 newtons being applied to it, and then you say it's 4 newtons. Well, 24 newtons is your applied force, but 4 newtons is the net force. And so that automatically tells you there must be a 20 Newton force coming in from the other side. Same goes for this guy. You might say, okay, so find this at 12 newtons, but he's getting 24 newtons from there. Where is it all going? Well, he's applying 12 newtons back to this guy as well. And again, the net force on him must be 4 kg times 2 meters per second squared times 8 newtons. So again, the key thing is, as soon as you find the acceleration of the whole system, which is really easy to do because you're simply dividing the force by the mass, you get the acceleration of each one of them, which automatically gives you the net force on each one of them. And again, keep in mind that if they ever ask the question, well, what's the force that applies back on that? It's just going to be the negative of that force. Do keep in mind Newton's second law when it comes, Newton's third law, when it comes to that. So I'll see you later on another video. I hope this kind of helps.